Jai Hind everyone. Welcome to Raghu Sainik School online classes. Today we are discussing the very important topic in our all entrance examinations regarding to math syllabus, that is real numbers. This is very important topic in CBSE 10th class and state 10th class also. So listen carefully. Right. Before entering into the real numbers, let's discuss some types of numbers. In that, very important is that is natural numbers. Natural numbers. The numbers used for counting and computing are called natural numbers or counting numbers. They begin with 1 and have no end. 1, 2, 3, 4 and so on. These type of numbers are called counting numbers or natural numbers. Whole numbers. Natural numbers along with 0 is called whole numbers. Very important. They are denoted by W and they are 0, 1, 2, 3, 4, 5, 10 and so on. Even numbers. The numbers which when divided by 2 gives remainder 0 are called even numbers. Very important. Or two multiples. Two multiples are even numbers. 2, 4, 6, 8, 10, 12. Very important. The general form of the even number is 2n. Very important thing. The general form of the even number is 2n. The next number series is odd numbers. Odd numbers. The numbers which when divided by 2 give 1 as remainder are called odd numbers. They have no end. 1, 3, 5, 7, 9, 11, 13, 15. These are odd numbers. The general form of the odd number is 2n plus 1. Very important. 2n plus 1. So here we learned about natural numbers, whole numbers, even numbers, odd numbers. These are all we discussed about type of numbers. Next important thing is prime number. With the prime numbers are very important. If you are good at prime numbers, 50% of the number system it will be very easier to you. A prime number which has only two factors, they are 1 and the number itself, then they are called unbreakable numbers or indivisible numbers or prime numbers which doesn't have factors. 1 and itself the every number has, but prime numbers doesn't have any factors. The very important. They are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. 1 is not a prime number, not a composite number. 2 is the only even prime number. Very important. Even every competitive exam we get the question like this. What is the even prime number? 2 is the even prime number. Next, composite number. Other than prime numbers, they are composite numbers, or a number greater than 1 and having at least one or more factors other than 1 and itself are called composite numbers or multiple numbers or breakable numbers or divisible numbers which have more factors, 1 and itself and more. 4, if you write the factors of 4, we can write 1 into 4, it is 2 into 2. 1 and itself is factors and other factor is 2. Therefore, 4 is the composite number. Okay, that is the difference between the prime number and the composite number. Prime means having only two factors. When it is composite, more than two factors. Okay, next, twin prime numbers. What it is? Twin prime numbers. Any two prime numbers whose difference is 2. Very important. Twin prime numbers means whose difference is 2. Two prime numbers must be two prime numbers. Must be two prime numbers having difference is 2. 5 and 7, the difference is 2. 11 and 13, the difference is 2. 29 and 31, the difference is 2. So these are pair. This pair is called twin prime numbers. This pair is called twin prime numbers. Okay. Next, very important, co-prime numbers. It is not belongs to prime number series. It is co-primes means it is any two numbers which have no common factors except one are called co-prime numbers. 5, 6, 9, 10, 9, 16, and you can easily remember any two consecutive numbers also co-prime numbers. Any two consecutive, if you take 1 and 2, 1, 2, if you take 1, 2, the factors 1 only. If you take 3, 4, there is no factors, common factors. That type of numbers are called co-prime numbers. So in this, prime numbers, composite numbers, twin prime numbers, co-primes. This is all about the prime number series. This is the very basic thing. If we have good idea about in this, then and only we are able to go for the next. Okay, pause the video and recollect, write in your separate notes. Okay, thank you. Next, integer. The next number series is integers. Integers also called as complete numbers. Integers. All natural numbers comes from 1, 2, 3, 4 and so on, 0 and negative of all counting numbers. That means positives, 0, negatives are called integers. That is -1, -2, -3, 0, 1, 2, 3. This set of numbers is called integers. What is the observation of this integers? Are clearly the set of positive numbers, the set of natural numbers, and the set of all included in the integers, which means the set of natural numbers are subset to the integers, and also set of whole numbers is subset to integers. So what are integers? Integers are the complete numbers without fraction. Without fraction is called integer. It's called a integer. Next, rational numbers. Very important. The whole concept depends upon these rational numbers. What are rational numbers? A number in the form of p by q. A number in the form of p by q. Which is in the form of p by q. A number in the form of p by q where q is not equals to 0 and p and q are integers. A number in the form of p by q in the form of p by q form, and where q must be not equals to 0, which means if it is 0, that is called undefined. Therefore that we called a rational number. P by Q form, that P by Q form must be in lowest terms, which means all the cancellation after the cancellation. Okay, P and Q has no common factor other than 1 is called a rational number. What is rational number? A number in the form of P by Q where Q not equals to 0 and P and Q are integers and P and Q is in the smallest form, that is lowest form. P and Q has no common factors other than 1, which means P and Q must be co-primes. Then the number is called rational number. Some of the rational numbers are 2 by 3, 1 by 4, 17 by 11. 2 is also a rational. Why? Because it can be written as 2 by 1. Minus 5 is also a rational number. Why? Because of we can written as minus 5 by 1. Okay, this is all about the rational number. Okay, next. This is all about the number series regarding to, it is a basic, it is not in any book, but why I am telling is that must be, you must aware of these basics, then only you are able to go for the next concepts. Okay, when it comes to our textbook, well, okay, I have to discuss some things regarding to your preparation. You must be good at first, you must be good at your textbook, good at your text. You must good at text. First complete the text, then come for this video, and then next chapter wise we will discuss the question and answers regarding all the competitive exam, whether it is Polytechnic, APRJC or George JC CET, Triple IT, or any competitive exam where it is FITG, where is Akash, all the questions will be discussed here. Okay, please like, share and subscribe to our channel, then you will be getting more videos. Okay, right. Now we are entering into the core concept of the real numbers. The first one is Euclid's division lemma. Very important. First I will discuss with the numbers, then I'll give the statement. The 12 is the number can be written in the form of 5 into 2 plus 2, means 12 can be written as 5 into 2, 10 plus 2. That is, this is the quotient, this is the divisor, this is the remainder. That you have to remember. If you take any number, I will take the 17. 5 into 3, it is 15 plus 2, it makes as 17. This is called Euclid's division lemma. Dividend is equals to divisor into quotient plus remainder. You have to remember. No teacher teaches like this. Please listen carefully. What is Euclid's lemma? Dividend is equals to divisor into quotient plus remainder. Okay, let's see the statement. Given positive integers a and b, there exist whole numbers q and r satisfying a equals to b into q plus r, where r lies between 0 and b. Okay, what I am saying is that a can be written as b into q plus r, which is a is the dividend, b is the divisor, q is the quotient, r is the remainder. You must remember like this only. Okay, the statement is any two positive integers a and b, there exist whole numbers q and r, which is satisfying a is equals to bq plus r. Okay, This is very important. In your exams, they can ask, write 157 in the form of Euclid division lemma. We can write it as 50 into 3, 50 into 3 plus 7. Okay, here it is 50 is A, B, Q is R, Q is 3, 7 is R. Okay. This is Euclid division lemma. Okay, if you have any doubts, you can ask in the comment section and I will give reply as soon as possible. This is about Euclid's division lemma. The next point in our real numbers is the fundamental theorem of arithmetic. Every composite number, that's why I have given the brief idea about composite number at the beginning of the video. What are composite number? Having more factors, can be expressed as of product of primes, and this factorization is unique except for the order in which the prime factors occur. This is all about composite number can be expressed in the multiples of prime numbers. That is called the prime factorization. Very important. We discussed the prime factorization in different concepts like LCM, HCF and so many things. That is called fundamental theorem of arithmetic is that composite number can be expressed in the multiples of prime numbers. Okay, let's take some examples. 10 is a composite number. 10 can be written as a form of 2 into 5. 2 is a prime number, 5 is a prime number. Okay, and take the another example of 24. 24 can be written as 2 into 2 into 2 into 3. 2 2 is 4, 4 2 is 8, 8 3 is 24. This is called fundamental theorem of arithmetic, which means that a composite number can be expressed in the multiples of or the factors of prime number. That is called prime factorization. Okay, next point is that every composite number can be uniquely expressed as the product of powers of the primes in ascending order or descending order. The same thing, the extension of that before one. Okay, therefore this can be expressed as 2 cube into 3 power 1. So powers of the prime numbers. Okay, this is all about the prime factorization. Okay, next very important is that this principle can be asked in your, sure you will get the question about this one. Let a be a positive integer, p be a prime number. A is an integer, p is a prime number. You must remember, a is an integer, p is a prime number, such that if p divides a square, then p divides a. If p divides a square, must p divides a also. Very important. If you take the, don't remember blindly, just go for with the practical examples. If I take the 4 square is equals to 16. If 2 divides 16, yes, it divides the 16. 2 must divides the 4 also. Yes, it divides. Take another example. Any example. If take 9 square is equals to 81. 3 divides 81. At the same time, 3 divides 9 also. If a number If a number divides a square, the same number will divide the its also. Okay, this is the very important concept. If a be a positive integer, b be a prime number such that p divides a square, then p divides a also. Okay, this is the very important concept. Next, there are infinitely many positive prime numbers. Obviously, there is no end of any number series. If there are infinite number of prime numbers are there. Okay. Next point. This all come to you as a MCQ questions. There are dash many positive prime numbers are there. The answer is infinite. Every positive integer different from 1 can be expressed as a product of non-negative powers of 2 and an odd number. Okay. A positive integer n is prime if it is not divisible by any prime less than or equals to root n. If n is a prime number, there must be a no factor itself. But if it is divides by an irrational number, that is root n. Why? Because of n can be written as root n whole square, that means root n into root n. Therefore, the factor is root n. Okay. If we take the root 2, is it, sorry, 2 is a prime number, it is divided by the root 2. 3 is a prime number, it can be divided by the root 3. The answer is root 3. Why? Because of 3 can be written as root 3 into root 3. Okay, right. If p is a positive prime, then root p is a irrational number. Obviously, we discussed in the previous point. If p is a prime number, root p must be a irrational number. Why? Because of it cannot come out from this root. This cannot be expressed in the form of p by q. That's why root p, if it is root 2, root 3, root 5, root 7, root 11, root 13, root 17, these are all irrational numbers. Why? Because of the value in the root doesn't have factors, which means which cannot out from the root. That's why it is a irrational number. Okay. That's why I have briefly discussed about the prime number. Prime numbers means no factors. If it is no factor, that is means no root. Okay. Next, very important, terminating and non-terminating decimals. Terminating and non-terminating decimals. Let x be a rational number. X is a rational number whose decimal expansion terminates, which means this terminal expansion is terminates. Which rational numbers means p by q. Is it right? P by q. We can write in the form of the numbers which can be written in the form of p by q, then are called rational numbers. When it terminates, if the q it is in the form of 2 power m into 5 power n, then only the x can have terminating decimal. Let go with the example. Let's see 7 by 10. This can be written as 7 by 2 into 5. 2 power 1, 5 power 1 means in denominator we must have 2 and 5. Then 2 only or 5 only, you will get the terminating decimal, which means it can be written as 0.7. It terminated at 7 only. Okay. if an expression, if a rational number must be a terminating, that denominator must be in the form of 2 power m into 5 power n. It is nothing simple as that. If you have 2 in any fraction by 2 or by 5 or 2 into 5, then only terminating. This is as simple as this. In any denominator, if you see 2, if you see 5 or if you see both, then it is called terminating decimal. In exam, they will ask which of the following is a terminating decimal and which of the following is not terminating decimal. Very 100% you will get the question from this point. What is that? If a rational number must be terminating when the denominator in the form of 2 or 5 or 2 into 5 expressions, then only the rational number is have the decimal expansion terminates. Okay, very important concepts. If you are not understand this, please comment. I will make this separate video for the doubt session. Next, this is a continuation of the previous point. Let x is equals to p by q is a rational number such that prime factorization of q in the form of 2 power m into 5 power n, where m and n are non-negative integers, there has a terminating decimal. If it has 2 into 5, it is terminating. If it is not 2 into 5, it is non-terminating. It is terminating because of the prime factorization in the form of 2, 5. Understood? Right. This is non-terminating. What is non-terminating? Non-terminating means not in the form of 2 power m, 5 power n. It may be 3, 7, 11, 13, 17, whatever it may be, without 2 and 5. Okay. 6. So you can say that, sir, 2, it can be written as 2 into 3. No, it has to have only 2. Then only it will be terminating. Okay. Got the point? Right. Next, logarithms. Very important concept regarding to your real numbers. In algebra, you will get the total about what is base, what is power, what is next. Yes, this is called a power n is equals to x. What it is? A power n is equals to x. A is called base. A is called base. A is called the base, n is called the power, okay, x is called the exponent, okay. Then log x base a is equals to n. Very important. If you write a number in logarithmic form, yeah, I will give you a good trick. Okay, first listen to this. A power n is equals to x. If a power n is equals to x, if you write the same thing in logarithmic form, log x base a is equals to n. Okay. Trick is that base is always base, exponent is always exponent. Okay. In logarithmic form, the number what we write here, it is called base. One number it is called exponent. Okay, that's why base. What is the base here? A. That's why a came here. What is the exponent here? X. X came here. This is a power. Power is equals to this. Okay, let's write some examples for this. Okay, 2 square is equals to, sorry, 2 power 4 is equals to 16. 2 power 4 is equals to 16. If you write this in our base logarithmic form, log base 2 exponent is 16, the answer is 4. Okay, this is how we need to convert exponential form into logarithmic form. 3 square is equals to 9. What is the base here? 3. Therefore, log base 3 exponent 9 is equals to 3. That's it. If you take 4 cube is equals to 64. That is log 64 base 4 is equals to 3. That's it. You can write the n number of examples. 5 cube is equals to 125. That is log 125 base 5 is equals to 3. Okay. This is the thing. This is how we have to convert a exponent into logarithmic form. Next, very important, laws of logarithm. Laws of logarithm very important. Okay, a power log x base a, when this base and this base are equal, the answer would be the exponent. Okay, all these laws are explained in your textbook, in your whatever it may be, the CBSE, NCERT or else state board. All these have the clear explanations. In this I am discussing just the formulas. A power log x base a is equals to x. Log xy base a is equals to log x base a plus log y base a. If it is multiplication, it would be plus. If it is division, it would be minus. That is the thing. If it is power, it comes to front. That is log x power m base a is equals to m log x base a. Log x base a can be split. It can be split by 2 with a different base, that with the same base, that is exponent. Okay, these are the 5 formulas are very important. What are they? A power log x base a is equals to x. Log xy is equals to log x plus log y. Log x by y is equals to log x minus log y. Log x power m is equals to m log x. Log x base a is equals to log x base e by log a base e. Where it is divided. Okay, this is all about today's class. This is all about the real numbers. Listen the video 2 or 3 times, then and write the notes. If you have any doubts, please ask in the comment section. You have to practice more, and I will supply material. Okay, as soon as possible, I am creating a Telegram group. In that I will export all the PDFs of the class. You will get there. Thanks for watching. Please like, share and subscribe to the Raghu Sainik School YouTube channel. Here you are getting all the classes for free, no cost. For no cost. Please share these things with all the 10th class students. This is very helpful to them. Thank you so much.